don't hear myself, so it's, now I do. Excellent. Thanks for showing up late in the afternoon for a repeat of a session that I did yesterday. The nice thing about a smaller audience here is we can have more of a discussion and less of a one-way transfer, if you'd like. My name is Steve Schmidt. I'm the Chief Information Security Officer for Amazon Web Services. What I want to do today is talk a little bit about how we view cloud security in general, to begin with, and then the specifics about how we implement it within AWS. And how you view the security process and paradigm is almost as important as the implementation that you use down the road, because it informs the customer of a lot of the bits and pieces about how we do our job, the way we think about the threats that are around us, and how we focus on making sure we're doing the right stuff to protect their information. One of the fun things about cloud security, at least from our viewpoint, is that it is universal. Universality here means that whether you're the guy with a credit card who comes in and spends 10 cents with us, or heck, uses our free tier, or the biggest contract that we have outside of Amazon.com, you get the same access to security. This is not a situation where you have to spend extra to get the additional features. It's not a situation where you have to spend extra to get the basic stuff that everybody needs, regardless, one or the other. Pardon me if I'm a little bit hard to hear here. I'm losing my voice after talking so much. And there we go, finally flipped. Visibility in cloud security is something that's a little bit different than a lot of on-premise architectures as well. The fun part about cloud security visibility is that in an on-premise environment, and this is a conversation we have with CIOs quite often, it starts off with really, really basic questions. What do you have? How do you know what's in your environment right now? You end up asking that question. Some CIOs sit there and start looking nervous. Some folks start getting concerned because they don't know the answer to it, and others say, I know. Excellent, great, how do you know? Well, I take an inventory once a year. Like, okay, cool, that's a good step in the right direction. However, is it a better scenario if you can tell with specificity every single object, every single piece of information you have with us, every resource you're using from us, every firewall rule, and you can tell it as often as you'd like? That could be once a minute, if you'd like. So it gives you some really, really powerful tools into the visibility of your infrastructure. And with that visibility comes your chance to decide on risk management. Because remember, you can't protect what you don't know about. And you can't decide how to protect the material that you do know about without the specifics of what are the exposures, what are the networks it's connected to, where did it come from, what version of what operating system am I running, where do the applications get started up from, or even which one of my employees did this. Those are all things you can figure out in the cloud environment using our APIs or the console that we present to you. How do you know things are right for your organization? The audit process is really, really useful to us in these circumstances. Auditability to us is our way of having a conversation with the customer about the way we practice the art and science of security. And security is both an art and a science. It is a combination of good judgment as well as good tools, good capabilities, the ability to choose wisely when deciding how we're going to execute parts of our job there. The way we have that conversation with customers requires a common language, just as we all speak different languages. There are many different languages spoken in the audit world as well, so we have to understand and behave in the ones that our customers are asking for. I'll talk in a little bit about what those are. Out of that audit process come a series of artifacts. Those artifacts are the proof that we are doing what we say we are doing. And that proof is made available to the auditors who act on behalf of our customers to examine what we do and how we do it. The bottom major bullet on the right side, logs. This is an area that I focus on very closely when I'm having discussions with customers. How many people here can recreate logs once they've been set to dev null? That would probably be an interesting feat if you could. But basic here is logs are fantastic, they're useful, but you gotta keep them. The good news is keeping logs in the cloud is trivially easy. The wonderful thing about stuff like S3 is you can store stuff very inexpensively, keep it forever, and you know what? Once you decide that it's been sitting around for a while, you can move into Glacier and keep those logs for a really long period of time for very, very inexpensive rates, especially when you consider the compressibility of log files is tremendous. So the important part out of that is get the logs generated, get them off of where you generated them, and keep them. That way you can go back and look at them later. And the go back and look at them later is as important as the process of keeping the logs. How many people would love to have a conversation with your boss where you had a problem and the boss says, well, did you look and see what happened? Yeah, we had the logs and we saw it in there. Why weren't you looking beforehand? Take a look and see what's in your logs. And in many cases, an interesting point here, log analysis is not just the prospect of identifying specific bad instances of behavior. In many circumstances, the absence of a log that you expect can be as illuminating as anything else. So when you look at large-scale operations like Amazon's, we generate trillions of log records every day. And we analyze those sets of logs to look for specific expected behavior. So are the machines doing the things we expect them to do with the frequency we expect and giving us the answers that we expect from the log systems? If there's something missing from that process, it's telling us there's something wrong going on. I don't know what it is yet. It could be a simple malfunction, but it also could be a situation where something inappropriate is occurring. So it gives us a clue. We want to go and take a look. So the absence of logs is as useful as the presence of logs itself. Transparency, again, this is about auditing. This is about the language we speak when we talk to our customers about how we practice security there. ISO 27001, the piece at the top, is the language that we speak to most of our European and Japanese customers. We use the ISO 27002 control sets when we go through this particular evaluation by the certification organizations. SOC 1 and SOC 2 tend to be North American focused, so our US and Canadian customers tend to like those. It's based on AICPA rules. FISMA is a US federal government evaluation process, DICAP, a Defense Department evaluation process in the US federal government, and of course PCI, the Payment Card Industry Association. Amazon AWS is a PCI Level 1 service provider, so if you have a payment card processing effort that needs to go on within your AWS environment, we can help you by taking away a good portion of the controls that you have to comply with and doing those on your behalf, then giving you the evidence from our PCI QSAs that'll help you support your own evaluation process. People often ask, really, that the cloud can support PCI? Yeah, we've got a very, very large customer who's PCI compliant, who runs on AWS, and that happens to be our mothership, Amazon.com. Security is a shared process in AWS. If there's one thing that I have to get right in any conversation that I have with CIOs, well, heck, anybody who I'm talking to in the security industry, is what is my job versus what choices do you get to make in the security process? And I say choices that you get to make because security is not a binary decision. You're not secure or insecure. You're in a situation where there's this gray area in the middle and you need to decide what's right for your business. I can design you an absolutely secure system by putting your data on a hard drive and burying it in a block of concrete. It's not terribly useful to you from a business perspective. So what we have to do is give you the tools to make the decisions that allow you to give the exposure you need for the information that you want while having the controls in place that ensure that you have the security that you require, your end customers require. On the left side, in the bottom of the screen there, you'll see the AWS responsibilities in the shared responsibility model. In EC2, it's sort of the canonical example of shared responsibility. If you think about the stack here, we're responsible from the concrete up to the hypervisor within the virtual machine environment. Above that, it is the customer's choice which OS they use, how they configure it, the applications that they install, the firewall rules that are present on those virtual machines. And one interesting thing, by the way, firewall rules as represented by our security groups. It's the one point within that customer process where we require something from you from a security perspective. We think that it's just good internet hygiene for every virtual machine to have a firewall on it. So we require it, and that firewall starts off closed. You have to decide how you're going to open up the firewalls on your virtual machines. We think that one of the major points that we like to get across with folks is drive down the security barrier. You know, Werner Vogels talks in his presentations about the absence of the moat around our cities now. That's true in network environments, really, really true in network environments. A perimeter firewall is a great place to start, but it's an egg. Eggs make great omelets, but they're not really useful for computer security. Relying on an eggshell is going to shoot you in the foot if you don't take advantage of collapsing that perimeter down to as close to the data as you can get. And I'll talk about how we can get closer to the data even than the virtual machines. Security is familiar. The practice of security in a cloud is not fundamentally different from that you do in your on-premise environment right now. And the best way to evaluate that from our perspective is the control objectives that we use for the SOC 1 and SOC 2 evaluations. Starting off with the security organization itself, those are the people on my team, the folks who do the work every day. In fact, a lot of them are sitting in the back heckling me right now, who are here to make sure that we keep an eye on what we're doing, that we take advantage of the tools that we give them internally, that they know how to respond to incidents when they occur, and that's the last control listed on the page here, and that they have the right training and access to materials that are required to do their job. Now, those are Amazon employees. The Amazon employee lifecycle is important to you in understanding our humans. What access do they have to your data, and how do we evaluate whether those people should be permitted to have access to your data? Now, this varies how we evaluate our employees based on where they're located around the world. The laws and regulations vary. So, for instance, in the United States, when an Amazonian is hired, we do a background investigation on that person, taking an examination of things like their credit history, their criminal history, whether or not they're current on their debts, whether they have outstanding situations they haven't dealt with from a civil perspective. So are they being sued by somebody? Does someone have leverage on them is what we're looking for. We want to make sure that the people we're hiring are going to be trustworthy since they are getting close to your information. For the very high sensitivity positions, the people in the organization who are dealing either with security or things like identity management, as an example, we reevaluate them on a regular basis. So it's not that we do a point-in-time snapshot of who they are and what their level of trust is, but we keep looking back as they go on through their life cycle with Amazon. That's closely coupled to the logical security that we apply to our information and our networks. And logical security starts off with a premise. The premise is least access consistent with a job. So if you think about it this way, in a lot of companies, the system administrator has rights to access every system in the company. In fact, they're almost always one of the largest vulnerability points from a human attack perspective. If I can go after your credentials or compromise that individual, that means I've got access to every box in the company. Well, we believe in limiting the blast radius that any particular human is accessible to. So what we do is we confine our employees' access at the logical level to those systems that are required to do their job. And more importantly, we require that their manager reevaluate that access and positively reaffirm it on a regular basis. So for instance, every 90 days, the manager of our team members has to go in and say, yes, this particular human still requires access to those systems to do their job. Additionally, the system that sits behind all of our humans, in our case it's PeopleSoft, has some workflow intelligence built into it so that when you move between jobs, your access to systems from your old jobs automatically revoked. So if you change teams, your old access goes away. You have to provision new access to systems or services. Case in point examples there is if you have an employee who works on the S3 team, they deal with storage systems. They do not have rights to access the EC2 infrastructure. Someone on the EC2 team, as an example, does not have rights to access the S3 infrastructure. That way, we keep them confined to just the material that's required for them to do their work. Similarly, there are a set of safeguards that we put in place at the network layer separating our employees and their normal workplace from the data where the systems where the customer's data sits. Case in point example there. If I'm an EC2 team member and I'm sitting at my corporate desktop and I need to log into a system where our customers have their data, I can't go directly from that desktop to where the customer data resides. I have to go from the corporate network to a bastion host. A bastion host is a system that's designed specifically for auditing and access limitation that sits between the corporate network and the EC2 control plane network. Those two networks are not otherwise interconnected. So if I'm on the EC2 team, I have to log into that bastion host, and more importantly, I have to log in using a different set of credentials from that which I use to log into my corporate network. If you think about it this way, a common attack profile for many nation states when they are going after access to certain kinds of company data is to acquire legitimate user credentials from somebody who's within the company and then reuse them elsewhere. By using a separate set of credentials to access the EC2 network from the corporate network, we reduce the ability of attackers like that to go after our network. Furthermore, we do not permit the use of usernames and passwords on the EC2 network. The only authentication process that we permit is using SSH with public key cryptography. So therefore, we don't allow people to have a username and a password that might be sniffed somewhere else and used to access the EC2 network. It's just good hygiene to have a separate set of credentials, and it's really good hygiene not to use passwords. Password authentication is shady at best. Secure data handling. You entrust us with your data. We store it on storage media. When that storage media breaks or reaches the end of its life, we have to dispose of it. It would be a horrible scenario if we disposed of customer data inappropriately. So we have a set of very clear rules that are implemented across our data centers on how to dispose of things like hard drives. Going back to a lot of the Amazon design philosophies, simplicity is one of the most important precursors for success in implementing controls. If controls are complicated, people get confused, they make mistakes. So what we've done with our data centers is make a rule that says no hard drive shall leave our facilities intact. It's really easy for the data techs to evaluate. Here is a hard drive, there's the door, it cannot go out. They don't have to make a decision, well, was this one properly erased, or did this one contain customer data or not customer data? No. Make it straightforward, make it simple, make it easy. So what do we do with those drives? Well, you do two different things depending on whether the drives are spinning media, magnetic media, or SSDs. They require different destruction processes. The first thing is for spinning media, we degauss them. And then we destroy them using either a hydraulic punch or we chip them into pieces. Now, I must say that it is kind of fun to go and throw hard drives in a chipper. But the net result is that you have a very clear indication that the media has been destroyed out the other end. SSDs, on the other hand, cannot be degaussed. So what we have to do there is use a different chipping mechanism that makes smaller pieces so that we ensure that every individual chip that's on those drives has been destroyed appropriately. Again, a really straightforward way of understanding, okay, I've got a bunch of garbage that came out of a chipper, yep, that can go out the door. But this drive is intact, it cannot. We apply that to other things as well. In many circumstances, certain types of RAM that come out of machines, for instance, are not permitted to go out the door intact, it has to be shredded. I'm sorry. Physical security. Is Bill in the back of the room? He can close his ears if he is. No, he left, good. He's the guy who runs physical security for me, and I say this in the talks, physical security is dull, it's boring. That insults him horribly, but that's the bottom line truth. But it's also foundational to everything that we do. If you keep the right people in the right place and keep the wrong people out, then you're in a much better place than you are when someone's plugging things into your networks and doing other unfortunate stuff in your data centers. Physical security is a really well-known science. It's something that a lot of people practice well. It's something that takes a lot of attention to detail to do right. Ensuring that you've got the right guards, that they have the right training, that you have the CCTV installed properly, that you evaluate that you're recording it right, and you evaluate you keep the material for the appropriate period of time. The good news from the customer's perspective is we do that on your behalf, and our auditors check. All the things that are in control objectives up here, by the way, are items that our auditors evaluate during the process of a SOC 1 or SOC 2 audit. So they will come into our facilities and say, you have cameras at 67 different locations here. Show me the view from camera 25 that shows the loading dock door number 1. And we have to pull it up and show it to them. And they say, okay, I want to see the video that you recorded from that camera on June 24th from 9 a.m. to 10 a.m. And we have to pull it up and show it to them to demonstrate that we actually take the recordings that we say we do and that we keep them for the amount of time that we say we do. And I say they keep the amount of time that we say we do because that varies across the world. There are some countries which have different regulations about how long we can retain CCTV, so we have to be compliant with the local rules and regs. Environmental safeguards. Data centers contain lots of machines. Machines generate heat. Heat has to be taken out, and machines don't work terribly well when power doesn't go in. So environmental safeguards are all about ensuring that the infrastructure that supports the HVAC, the power supplies, et cetera, is properly operating and properly protected. It talks about how we test that infrastructure and how we keep an eye on its normal functioning during the day. Again, not a glamorous or fun task, but critically important to our ability to provide services. Change management. This one's kind of interesting. Werner talked a lot in his keynote about change management. I don't know if you guys got a chance to watch that, but it's something that we do in a way that's a little bit different from a lot of places out there. If you noticed when you started working with AWS, we don't have maintenance intervals. It's not like we say that we're going to be offline between midnight and 3 a.m. every Wednesday. That's just not possible in the world that we live in. So we have to continuously deploy software to many machines around the world. The important part about the change management process is that changes in our production infrastructure have to be authorized, and the deployment process has to be regular, and it has to be constrained. What do I mean by that? I'll get to in a sec. The authorization process is pretty straightforward. Every change that you wish to roll out into a production environment has to be approved. And the approval that's required varies based on the impact of that change. So if I'm making a change to an HVAC control system in one availability zone in one region, that may only require the data center manager's approval to do. But if I'm making a change to the S3 infrastructure that touches every single node within S3 in a particular availability zone, that's going to go all the way up to a VP for approval because it's a very, very intrusive change and has a big impact radius. Similarly, the process of rolling out new software is a fun one in a continuous deployment environment. We do a process that is, and Werner describes in detail how it evolves over time, that involves testing changes in the local environment, testing them in a beta environment, and then rolling them out into one-box scenarios in some circumstances. That's where literally you apply it to one machine that's in one availability zone that's in one region, letting it bake. If that succeeds, roll it out to every machine that's in a particular availability zone. And notice I say a particular availability zone. There are a few cardinal rules that we have for change management. You only affect one availability zone at a time in one region. That way our customers who are depending on the availability story of multiple availability zones or different regions around the world are not at risk of being affected by a change that's deployed simultaneously elsewhere. If that succeeds within that one availability zone, we then roll the change out to another availability zone in a different region. So we then roll around the planet doing one AZ at a time until we get all of them done. Data integrity, availability, and redundancy is all about do the processes and procedures we have in place to ensure that your data stays intact on our systems work. S3, for example, as you've heard, is 1 trillion objects being stored. And if you listen to Alyssa Henry's talk today, she pointed out that occasionally people talk about the theory of errors and, well, this may happen 1 in a billion times. Well, with 1 trillion things, that becomes a very real possibility as opposed to merely academic exercise now. So we have to have active processes in place that don't bring the walls down, that allow us to ensure that your data is intact. It's the same as when you gave it to us, and that we give it back to you when you ask for it in the same fashion, intact and sane. Incident handling. This is all about what happens when things go bump in the night. If something goes wrong, and this is both from the operational perspective but also the security perspective, have our teams had the training? Do they practice what they need to know to mitigate instances, to respond to things? And do they have the tools to do so? The fun thing about this is what we call game days, where we literally will practice what we do, where the people practicing don't necessarily know that it is a practice interval. So with the security team, for example, what we'll start off with is injecting what appears to be completely legitimate scenario events into our normal process of operations. Okay, you've just been notified by a law enforcement organization that they have a search warrant that they have to serve. Can you produce the forensically sound copy of the virtual machine for this particular individual who's concerned because the cops think they're involved in fraud or something like that? So we actually have to go through the process of ensuring that we respond within the SLA timeframes that are required, that we have the tools available, that the folks who are doing the work know exactly what to do, and that they can produce the material that it's needed out the other end. The important part about that is we should never, ever, ever encounter an incident handling process for the first time during an incident. It should be well exercised, it should be well understood, and everybody should be quite confident in what they're doing each time that's invoked. Okay, defense in depth. Defense in depth is something that's near and dear to my heart. It's something I started off with in a conversation earlier here. Confining your security layers to just one piece of your environment is a huge mistake. We give you a lot of tools, and there are a lot of other things that you can do using our third-party partners systems to really crank down the blast radius around your data. For example, there are a lot of scenarios where limiting access to individual data elements makes a lot of sense, rather than confining things to just the top-level virtual machine, as an example. So case in point, a customer we have who is a news gathering organization gets lots and lots of photo submissions from their reporters who are out in the field. Very, very sensitive activity for both political reasons in some parts of the world, but also for competitive reasons in a lot of other parts of the world. So what they did with S3 was they designed a set of access controls and limitations on their buckets that allow them to have any of their people submit data into them, but not read any of the data that's already there. And the people who are authorized to read that data, those folks who are within their organization who are actually making the decision, do we post this one on the website or not, were only permitted to access that information when they were on their corporate network within their assigned working hours. Yes, you can get down to that level of granularity with the security controls that we give you. Say that, for instance, this guy is allowed to access that S3 bucket and read the contents, but only when he's at his corporate desktop and between the hours of 9 a.m. and 5 p.m. Monday through Friday. You can put that level of control in the data if you want to within our environment. So, again, these are decisions that you get to make. We don't force them on you. We don't force you to do these things. It's you decide what's right for your business. You decide what's right for your particular set of data. Physical security. Our buildings themselves are really big data centers. They're really boring to look at from the outside, big slabs. Nothing's terribly exciting. We have the perimeter controls that you expect if you've ever operated a large data center. There's nothing exciting about that. We're talking about fences here and guards and that sort of thing. Two-factor authentication requirements for entry into our building. That takes place at least twice in the process of going in before you gain access to anywhere that there's a customer data or network. The second to last, yes it is, second to last bullet, is one of the most important here, though. Needs-based access for AWS employees. If you ask an AWS employee, heck, if you ask any Amazonian where the data centers are, they will be able to tell you what part of the world they're in, the region. They'll be able to tell you what state they're in, if they're in the United States, or what city in some places like Dublin. But they won't be able to give you an address. That's because they don't need that information to do their job. It's irrelevant to most of them, so they don't have it. Now, security through obscurity is not sufficient in and of itself, but it's a starting point. Information control has to be consistent throughout an organization. It's give the people who are working in our place the access to information that's required for them to do their job, but no more. Now, the interesting side note, I bring this up every time I give this particular talk. I run security for the company. I don't have access to data centers without somebody else approving it. It's because it's not part of my normal job to be in a data center. So I have to ask somebody else's permission. They have to approve it in a ticket in order to enable my badge to get into those facilities. And oh, by the way, we don't use the same badge that we use for corporate facility access that we use for data center facility access. Again, it's separation of role and responsibility. That way, the people who work in our corporate buildings don't necessarily have access to any of our facilities without going through that extra step of getting an additional authentication token. Accesses are logged and, yes, I'm harping on this point, reviewed. We both log everything that takes place and we check. We go back and say, show me the approval ticket for this particular person's access as part of our normal business practice. And that is critically important to good hygiene in access control, is making sure that you are doing what you think you're doing and that your process is working right. Distributed regions and multiple availability zones. You've heard this story a lot as you're here, so I'm not going to spend a lot of time on it. The basic premise here is that we've got regions all over the world. You should use them both for availability and connectivity reasons, something that's close to your end users, but also in many cases for geopolitical reasons. We have customers, the US government, for example, who says to us, I'm going to use you, but you are going to guarantee me that my data never leaves the United States. in which case we're happy to say, sure, use any of our US regions. Your data stays within the United States unless you make a conscious decision to move it to another region. We have a lot of customers, in fact, many more customers, who say, I don't want my data going in the US. I don't want you moving my data around the planet randomly like some people do. I want it to be in EU West, as an example, in which case we give you that construct where you can place your data where you want to. In fact, we require you to tell us where to put your data. If you've ever interacted with our APIs directly, you will note that every single one of them requires you to tell us which region of the world you want that data put in. That way you make a conscious decision where your data is going to be located. Now, within each one of those regions are availability zones. You know why they're there, because you've heard this 20 times probably in the last 2 days. It's to give you the choice on what the availability profile of your information is. There are some services that provide availability through multiple data centers by default. S3, as an example, automatically replicates your information. But for others, like RDS, the Relational Database Service, you have to decide, do I want it in one availability zone or do I want it replicated into a second? And those are choices you get to make because perhaps for this particular database, it's dev test, I don't care if it goes away, I'm gonna leave it in just one AZ. But for this production database, I wanna make sure that's in multiple AZs. Network security. Denial of service attacks, they are just a fact of life. That is something that happens every day on the internet. It's something that we are, for better or for worse, quite experienced in dealing with and mitigating, and it's something that I have a lot of conversations with customers about. The fun fact about denial of service attacks are that we auto-mitigate hundreds of them every single day without the customers even knowing what's going on. Now, some customers will say, well, why can't you get rid of every single one? Why do I have to come to you sometimes if I'm being attacked? Because I cannot define a priori. I can't define in advance what is malicious activity. There are certain circumstances where completely legitimate activity could appear to be malicious. Case in point example, the situation where Michael Jackson passed away, a customer of ours spun up a bunch of virtual machines, hosted a bunch of tribute data on AWS. We saw a huge traffic spike going to a set of virtual machines, thought, whoa, denial of service attack, what's going on? When we started looking, it was completely legitimate. It was a traffic spike because they just announced this tribute site to the world. So that's why we cannot just go on the basis of, oh, strange traffic spike volume going on. So now, for denial of service attacks situations where we have customers who are particularly vulnerable, we encourage you to take advantage of the support options that are available. The support option is the path to get into our team and manage denial of service attacks appropriately, where we get rid of the attack traffic at the border before it ever hits your instances or services. Furthermore, working with one of the solutions architects can help you ensure that you architect your infrastructure to be resilient to DDoS attacks. The single best defense against DDoS attacks, besides avoiding them in the first place, is making it so that the attacker doesn't notice an appreciable change in your behavior. They get bored and they go away as a result, because they're trying to look for change in what happens with you. They want your site to slow down. They want traffic to stop flowing off of a service that you're offering. If you can automatically expand and contract your fleet of machines to absorb that traffic load, it's a great defense mechanism, so take advantage of it. SSL endpoints, this is for our APIs. We offer SSL endpoints on all of our APIs. Some of them are only available over SSL. We strongly encourage you to use them. Yes, we do use X509 keys or AWS secret keys to sign API calls, but I strongly believe in redundant and overlapping security controls. So use those that we give you, please. SSL is a good idea. Take advantage of it. Traffic spoofing is prohibited. Lots of people ask this, well, if I've got a virtual machine in there, can't I just generate all sorts of garbage traffic, throw it out on the internet, and annoy everybody? No, we know what IP addresses are assigned to every virtual machine, so we only allow traffic coming off of that virtual machine to have that IP address. And if you do enough of that kind of spoofing, you will cause us to become annoyed with alarms, and we will come and talk to you and ask why you're doing so. Port scanning, it doesn't work in large volume because we have alarms that trip, and we will auto-throttle traffic of certain types. So for instance, if you start annoying the internet by SSH brute forcing people, as an example, we notice that kind of behavior, we throttle it back and we stop it and we come and say, why are you doing this? Now, interesting side effect of that. We have a large number of customers who use our services for penetration testing of their own infrastructure that's internal to their organization. You can do that. You just have to contact us ahead of time so we whitelist your resources so our automatic response systems don't kick in and cause you a headache. It's a very easy process. If you go to aws.amazon.com/security, you'll find that there's a penetration testing authorization form. You fill it out. We validate that, yes, indeed, you do own the resources that you say you own. We say, OK, from what start date to what end date are you going to do your testing? We authorize it. You're whitelisted. You're good to go. So absolutely possible to do pen testing off of our services. We just ask that you communicate with us first. Packet sniffing doesn't work, and I'll show you a block diagram of a network later on and explain why. Security of EC2 is always a public topic, a popular topic for public discussion. We need to separate the examination of EC2 into two major parts. That's the host operating system and the guest operating system. The host operating system excuse me, is the part that we control. That's where our control plane software sits. It's where a hypervisor is installed, well, associated with it. And it's where we do all of our work. The guest operating system is the OS that you decide goes into your virtual machine. Now, notice that this is a little bit of a repeat of something I said earlier. Access to the host operating system is only permitted via SSH keyed access via the Bastion host for our AWS administrators. The most important part of that statement, though, is the second bullet there, which is all accesses are logged, and we audit that log on a regular basis. Because I want to know what all of our employees are doing when they're in contact with customer information and be able to identify exactly what they did while they're there. The guest operating system is something that you control at the root level. Unlike a lot of situations, maybe you used a hosting provider before, where they have access to your virtual machines in order to support you or whatever it was. We don't have access to any of the logical level of your virtual machine. Literally, we don't have credentials to it. When we generate credentials the first time, when you start up a new virtual machine, for instance, you get a Windows admin password that you've retrieved from us. Those are ephemeral, meaning that once you say, yes, I have it, you click that button on the management interface or you use the API to retrieve it, we don't have it anymore. And if you're following our best practices documents, you will immediately change that password or replace those SSH keys with ones that you generate yourself. We think that's a great idea. Sometimes that can be a little bumpy. Customers will come to the support staff and say, hey, I really like it if you guys could log into my machine and help me out. We can't do it. So unfortunately, that means that it's a little bit of an awkward situation sometimes. Customer-generated key pairs, when you launch an EC2 instance, for instance, you can provide us with the customer key pair half, and rather than generating it on EC2, and we will use that as your source of authentication and authorization. Firewalls, stateful and stateless, are present throughout our infrastructure. You got to have it. You got to use it. You get to decide what the rules are. All right? So within Amazon VPC, there are stateful firewalls on every virtual machine. In EC2 Classic, which means outside of VPC, they are stateless. You get to decide what those firewall rules look like. We strongly encourage you to configure them with the minimum level of access that's consistent with what you need to do to use your job. An example there of a situation where we might interact with you on your firewall logs is, if you'll recall, a few months ago, there was a problem with the RDP service in Windows, where there was a vulnerability. What we did then was look at all of our customers' rule sets for any Windows machines that were running in our infrastructure. And those who had the port 3389, the RDP port, open to the internet, we notified them that they might be susceptible to that Microsoft vulnerability and gave them instructions on how to reduce that vulnerability by cranking down the firewall rules. A lot of folks don't realize that you can do that, so we offered them some help in understanding how they can. Signed API calls. We want to make sure that we understand that you are who you say you are. That can take place two different ways, one using his X509 certificates, the second being using a AWS secret key. So you authenticate to us and authorize us to take actions by use of those keys. I talked earlier about the flow of packets within Amazon EC2. Here's a pictorial description of it. No slide deck would be complete without boxes with pointers and arrows. So here's one for you. The point here, though, is, that was a really bad pun. The reason I have this slide in the deck is it shows the flow between customers on the same droplet, on the same physical piece of hardware. Quite often, we will have customers say, well, if I'm on the same virtual machine as somebody else, can they see my traffic? Because we're both using network interface cards. No, they cannot. The reason is that firewall that's in the red on this slide down at the bottom, traffic has to go through that firewall before it can go even between virtual machines on the same host. And that's where we do the enforcement of the security group rules that you give us. Amazon VPC. I'm going to build this slide up quickly because it's easier to talk about that way. Near and dear to my heart, this is one of the first things that many of the folks who are here today worked on when we came to Amazon. This is a service that we offer to answer many questions, but the original one that was built for was a seemingly really straightforward request from a customer. Large financial institution in New York came to us and said, I have 9 data centers, I want to get rid of one of them. I want to use the cloud, but I want my use of the cloud to look like my traditional data center. I want to be able to use the same tools that I use to manage my existing facility. I want to use the same rules for separation of traffic between tiers in my infrastructure. I want to use the same IP addresses that I currently use because I'm happy with the enforcement processes I have and the auditing, et cetera. So VPC was born. It is a system that's designed to carve off a piece of our infrastructure and present it to you as if it were your own facility, and then allow you to make decisions about, do you offer internet connectivity into that infrastructure, or do you only perhaps connect it back to your on-premise installation? And that connection can take place back to the on-premise installation through one of 2 paths. One is an IPsec VPN tunnel. The fun part about that IPsec VPN tunnel is it is configured via an API. So you don't have to call us, you don't have to contact us. You literally use an API or a wizard on the graphical interface to create the endpoint for that IPsec tunnel, to provision it, to instruct us on what IP addresses you want to use, to establish the keying that's necessary for that. And then to make it even easier for you, we vend back to you configuration snippets that you can use to configure the device on your premise. And the device in your premise can be any one of a number of major brands. So if you're using a major Cisco product with certain versions of iOS, if you're using a Juniper product with certain Junos versions, if you're using an Astaro security gateway, Sophos bought them now, but we vend configuration snippets for them. Really trivially easy to set up a VPC connection back to your infrastructure. Now, okay, fine, IPsec tunnels are great. I like them, but they go over the open internet, which means there's a little bit of variability perhaps in packet paths, so timing changes, et cetera. What we suggest then is for customers who want dedicated connectivity, take a look at our Direct Connect service. Direct Connect is the means by which you can hand us a private Ethernet pipe in a number of places around the world. We connect it up to your VPC on one side, you connect it up to whatever other infrastructure you'd like to on the other, and you've got a private path that goes between the two, either at 1 gig or 10 gigs. Per second. So it gives you the real-life appearance of your own data center on a stick coming in to work with us. This gives you a little bit of a textual description of what I've just talked through. If you'd like to, we can talk about this later on in some more detail. We've got some pretty authoritative folks who give you some gory inside view on what VPC is, how it works, et cetera, and help you walk through some of the configuration options that are available. In fact, if you look on the screen right now, this will show you the different enforcement points where you can put controls in your configuration of VPC in the network. They're turning out salmon colored. On this slide, boxes are security group configurations that we require everybody to have. They connect virtual machines up to subnets. Subnets can have network ACLs applied if you'd like. They don't have to. There are routing table decisions that you can make on how your packets get routed between subnets, the internet, or hosts on your own premise. And then the connectivity decisions are down at the bottom, whether you go through a VPN gateway or whether you go back out through an internet gateway or through Direct Connect. Lots of different options for you to connect. If you want to take a picture, I'll even flip back. Go ahead. Okay. Dedicated instances. Some customers have come to us and say, I really love VPC. I love working in the cloud, but you know what? I want to be the only customer running on a physical piece of hardware. It gives me a sense of peace of mind. It means that I control who else is on that box, so I control the performance of it completely. We offer that driven by APIs using our VPC Dedicated Instances product. So literally, you can give us an API command that says, configure my VPC so that instances that are launched in it are dedicated. I'm the only one who's on that physical piece of hardware. There's a nominal additional charge associated with it. because obviously we have to reserve that whole physical piece of hardware for you. But in circumstances where customers are particularly concerned, makes sense. It's easy. It's something that's available for you. You can configure an entire VPC as dedicated. This is useful for some people who have specific configurations that meet particular regulatory requirements, as an example. They want to ensure that every machine that's launched into that VPC is on dedicated hardware. So you can flip that switch on the VPC, and we won't launch machines into it that aren't on dedicated hardware. We talked a lot about different security controls. You probably know that we've got the commercial cloud that we were talking about here, virtual private cloud, and the US Gov cloud that's available on AWS. People often say, what is the difference in the security between them? And the great part for everybody out there is the only difference between what GovCloud has and the rest of our infrastructure is GovCloud is operated by US persons. So there's no degradation, difference, diminution of security in any of our other service offerings because it's not part of a government infrastructure. We think that operating security at a level that's consistent with what we would want to be treated as is the most important thing, rather than trying to cut costs or corners. Security resources. I've talked really quickly here to try and cram a lot of information in a short period of time. Please take a look at the URL that's on the screen right now if you have not already. There is a great deal of detail on the security website. It gives you access to resources like our security white paper, the risk and compliance white paper. If you work with auditors, for example, the risk and compliance white paper is a great place to start to educate them about how AWS works, how we configure things. The security white paper and the risk and compliance white paper are updated regularly. If you recall back to some of the discussions that Werner had in the keynote address, he talked about the velocity of change in AWS and how many new services we launch on a regular basis. 158, I think, is what Andy Jassy said that we're going to be launching in this calendar year. The important part about that is we have to update these documents that describe the security parameters associated with any new service that comes out. So we quite frequently change them. Please check back on a regular basis. More importantly, let us know what you think. Do you like them? Are they sufficient? Do they give you the detail that you need to understand what we're doing and evaluate whether it's right for you or not? Let us know. We'd love to hear about it. And that is the end of my talk, and I'm even within 2 minutes.